Guys, welcome back to my YouTube channel. In this video, we'll be focusing on integrating by parts. We have given question 1. Is it mathematics and 5, by the way? You've given there question 1. 1 there. We've given question 1 should integrate here. This is question 1 should integrate. Should find the integral of x multiplied by 4 raised to the power of x multiplied by dx. All right, we're multiplying. Remember, when it's a product, if you have a product like this, if you have this situation, you're multiplying. Remember, if you're differentiating, you're going to use a product rule. Here we'll use also the formula that we have for the integrating. We call it integrating by parts, right? We'll use the formula. We know this will be the integral, the formula that will apply f of x multiplied by g of x prime dx must be equals to what? To f of x multiplied by g of x minus the integral of g of x multiplied by f of x prime dx. So supposed to apply that formula there. All right, this is what we have. So I will let you check. You choose what can be differentiated easy, and choose what can be integrated. Make f of x what you can differentiate easily. It's x, we know we can differentiate x easily. Then make g of x. Remember, I'll make f of x to be equal to that. I'll let g of x now, g of prime x, let g of prime x to be equals to 4 raised to the power of x. Right, then here you take f prime, you differentiate, this will give us 1. Then here you integrate both sides, where if you integrate, the integration of g of prime will be what? G of x. This must be equals, you integrate this is a it's a exponential function. How do you integrate that? G of prime will give us, we rewrite this as it is. We'll rewrite that as it is, will be 4 raised to the power of x. Remember, supposed to divide this by ln. You take multiply by the derivative here, derivative of 1. If you multiply on the bottom by derivative of 1 is simply of x. The derivative, you take the derivative of x, you multiply by it on the denominator, will be 1. So 1 multiplied by ln won't change anything. Multiply by ln, then you here you write what you have there on the base. What we have on the base is 4. You write 4 like this. All right, this is what we have. Now we can substitute on our formula. We have f of x, we have f of prime x, we have everything. We can use the formula then and pack everything. So that is what we'll have. So I'm still having the integral g of x here. We're supposed to substitute g f of x, it's equals to what? To x. So I'll have x multiplied by g of x. G of x is this, g of prime x there is 4x multiplied by 4x, then have dx here. This must be equals to f of x. F of x is what? It's x here multiplied by g of x. G of x is this, is that exponent there that we have, 4 raised to the power of x divided by ln 4 minus the integral of g of x. Right, g of x, we still have this, will be 4 raised to the power like that. Then f of prime, then f of prime multiply by f of prime is 1, so multiply by 1 we have our dx. So all right, then we apply the math. This is what we have. All right, then on our left hand side we still have this is what we're supposed to evaluate, to integrate. Then here on the side we'll have this, we have our x multiply, we still have this here, x multiplied by 4 raised to the power of x divided by ln 4 minus the integral of this. Now, right, how do you integrate that? How do you integrate that? The integral of this we have here, I forgot to write ln 4. The integral of that, we're supposed to integrate that. All right, this will give us what? The integral of what we have there. We want that integral, isn't it? So this will give us the same thing, isn't it? When we are trying to remember, 4 is simply just ln. This is a number. You can write this, or let me just rewrite this. You can rewrite this, the whole of thing, that to be same as ln, to be same as, or I can write that to be the same as 1 over ln 4 multiplied by 4x like this dx. This is simply just a constant, right? Simply just a constant. I can take this outside of the integral. I'll just take that. I'll have ln 4x over ln raised or 4. Take this outside of the integral. I'll have minus 1 over ln 4. The integral of 4 raised to the power of x dx. So this, as you can see, it's what we've started with. We'll integrate that. Right, on our left hand side we still have the ln x multiplied by 4 raised to the power of x dx. All right, so we're supposed to integrate this. So if we integrate these, guys, we have seen that the ln of this, the ln of 4x dx, we've seen this will be equals to 4x over ln 4. We still have this again in that space, so we'll put that on that space. We know we'll have this, we'll have that when we integrate that portion. So we still have our integral on our left hand side. It will be equals to x multiplied by 4x over ln 4 minus the integral minus 1 over ln 4. Okay, we've already integrated. Multiply by the integral of that will be 4x over ln 4 like this, plus constant what c, because we have integrated now, isn't it? So this is what we'll have then. All right, so as you can see here, we'll have ln multiplied by 4x over ln 4. So here minus, we have the same. If you multiply that, will be 4 raised to the power of x all over ln multiplied by ln is the same as ln 4 raised to the power of 2, because they are the same, plus the constant c. So actual fact, this must simplifies. This will simplify to this. So for that integral, the left hand side we still have this. will simplifies to that, will simplifies to this. That is what we have there as a ant. All right, so what we're supposed to integrate again, number 2, ln, integral of ln, the integral of ln x dx. Remember, we're supposed to use by parts. This is the same as ln, we have 1, it's the same as 1 multiplied by ln x dx, right? So I will let f of x to be equals to 1, then g of g prime x will be equals to ln x. That is what I will do. All right, or you can do n, it's up to you which one you can do. Someone can prefer to do like this, to let f of x to be equals to ln x. Someone can let g of x like this to be equals to 1. Anyway, it's one in the same thing. Okay, let us just continue with this one and see. So we know our formula. We know the formula that we're supposed to use is the integral of f of x multiplied by g of x dx must be equals to f of x multiplied by g of x minus the integral of g of x multiplied by f of prime x dx. Here we have prime also. So I will take f prime, then this ln, we'll know this will be same as 1 over x, we know that. Then here I integrate both sides, I will have g of x, this will give me what? Remember, this is the same as what? If you integrate, will be x. Remember, here it's the same as the x, like that. We'll simply have what? X. All right, so we can substitute on our equation, there. You can use this now. There, we know is what we're supposed to follow now there. All right, so f of x, there, f of x, we set f of x to be equals to ln. I'll have the integral of ln x, g of prime, it's 1 multiplied by 1, obviously simply ln, this is the x, will be equals to, there we have f of x, is what is ln, we'll have ln x here multiplied by gx, g it's x, there will multiply this by x minus here the integral of g of x, is x, as you can see there, multiplied by f of prime, is multiplied by 1 over x dx. All right, so the left hand side we still have ln, the integral of ln. Then here we have multiplying this, will have the same as x ln x minus the integral, this and this will cancel, of 1 dx, like this. All right, then we have to take our left hand side, we still have ln x dx. Then okay, here we still have ln x minus the integral of 1, the same as x dx. So the integral of ln will be equals to that when you're using the integration by parts. But let us not forget here to add our constant c, as always. Constant c, there even give you constant c there, you can put a constant c plus constant c, isn't it? So that is what we have. All right, number 3, we've given this now. The integral of ln of e raised to the power of x multiplied by sine x. That is what we have there. We have the integral of e x multiplied by sine x dx, if I'm not mistaken, but is what we have. Yeah, that is what we have. All right, so how can we partake this? This will be equals to what? So we know we'll use our integration by parts. We have the product, as you can see, the product. We'll apply integration by parts. We know the formula already will be integral of f of x multiplied by g of prime x dx must be equals to f of x multiplied by g of x minus the integral of g of x multiplied by f of x but prime dx. So we're supposed to follow this. All right, so I'll make f of x to be equals to what? I'll let f of x to be equals to what? Make the simpler one in there. We can make it to be equals to ln raised to the power of x. Then I can make g of prime x to be equals to sine x. So I will take f prime. This will remain the same anyways. Then take the integral both sides. I'll have g of x. The integral of sine is negative cos x, isn't it? We have our negative cos there. So we'll substitute on our formula. Let us use the formula. We'll continue there, substituting on the formula, the one that we have. The integral f of x, we said is this, would be ex multiplied by g of x, whereby it is sine x. We have equal sign f of x there. F of x, we said is this. It's e raised to the power of that. Then g of x is minus cos multiplied by negative cos x minus the integral of g of x. G of x is negative cos multiplied by negative cos f of prime. Here it's e multiplied by e x dx. This is what we have. All right, so this is what we have so far. All right, this is what we have. Our left hand side, we still have, sorry about that, on our left hand side we still have the integral of that multiplied by sine x. This multiply these two, will have negative e cos that, have negative e raised to multiply by cos x. Then let us take this negative outside of the integral, will be what? Positive. Then here we'll have the integral of cos x multiplied by e like that dx. All right, so this is what we have. So to integrate, we're supposed to integrate this, but as you can see, these are products. We're supposed to use integrating by parts again. We have to use integrating by parts for this portion, for that portion. Okay, I will just rewrite this portion here at the bottom. We have to integrate this cos x multiplied by e like that. We have to use integrating by parts again. I will let f of x to be equals to e raised to the power of x. Then I will let g of prime x to be equals to cos x. Then f of prime will be still the same, that won't change. Then we take the integral both sides. As we are taking the integral, this will be g of x. Then when you integrate this, it will give us sine. We'll have our positive sign, isn't it? Positive sine x. Let's integrate cos. So we'll plug our formula. Remember, we're focusing on this part, on that part there. So we'll plug. We know we'll use our formula again. We know the integral of f of x multiplied by g of prime x dx must be f of x multiplied by g of x minus the integral of g of x multiplied by f of prime x dx. So we said f of x here, it's e, so e raised to the power of x multiplied by g of prime. G of prime is cos x dx. F of x is still e like that. G of x is sine multiplied by sine x minus the integral g of x, it's sine. We'll have positive sine x multiply now again by f of prime x. F of prime is this, the we have dx. This is this part, only that part will be equals to this, there will be equal to that. All right, will be equal to that. So we know that this is what we had there on the top part. This is what we had there on our top part that we're supposed to integrate. All right. So okay, let me move this there at the bottom. All right. So we have this. On our left hand side, negative ex multiplied by cos x plus, but this we've said is equal to this on the top. We've simplified that. Cos will substitute there. It's what we have down the top. We have ex multiplied by sine x minus the integral minus the integral of sine x multiplied by e raised to the power of x dx. So notice something here. You should notice something. Check something here. Let me highlight with a different color. You see you have this integral there, and this, it's a one and the same thing. Check. When you're multiplying, order doesn't matter. This is a one and the same thing. Because we have minus, I can take this to the other side, right? So we can add this to the other side. If you add that, we'll have, remember now, I will add this. I can add this to the both sides. Since you have this as a like terms, I can add so if I'm adding this, obviously we're supposed to have dx. If I'm adding this and this will cancel, this will is like have 1, this will be like 2. The integral of e sine x dx must be equal to what is left here, minus e, isn't it, is what we have, minus e x multiplied by cos x plus, there we have ex multiplied by sine x, right? That is what we have. So divide this. I don't want to have the coefficient there. I will divide by 2. Therefore, if I divide by 2, both sides there, I will have this on the left hand side here. Divide all of this, dividing all of that. Now remember, this is minus, here we have a negative, here we have a plus. This is the same mathematically, this is the same as e multiplied by sine x minus, because of minus, you can write it here, ex cos x, right? So we have to divide by what? By 2. I will divide everything by 2 now. Since I said this, divide this by what? By 2. All right. Then this can be again the integral of ex multiplied by sine x dx can be equals to, now I can take this as a common factor, there will be ex, then divided by 2. I'm taking this 2 all into sine x minus cos x. All right, that is what we have. We have integrated. This will be equals to this plus our constant c. This is what we have now. This is what we will have. All right, we together then. This is how we integrate. This is what we call, this is our integration by parts. So far, that is our integration by parts. So that is it. That is what we have in this typical video. Do we have another question? This is what we have in this typical video. So thank you for watching. Stay tuned. Feel free to like and share, and to subscribe. Share this to your favorite classmates. You can subscribe also. Feel free to comment. All the best.